Okay, good morning class. So number 3, I hope you all know how to do it, but don't forget, as I mentioned before, all of this in your calculator must be in radian mode, okay? Because if it's in radian mode and degree mode, it will give a different answer. And then if you look properly, this is not degree, so definitely it means radian, okay? So as for this one, I noticed that, well, I'm just aware that you all have not learned it. So I just have to teach you here, just a very quick one and simple, because we are solving a trigonometric equation here. So what happened is, sine x is a function, okay? Sine x is a function. So it's just like a square. So for example, if we have x squared equal to 4, it's a function. So when we move it to other side, it becomes square root, isn't it? So it's a square root of 4 like that. So it's the same thing. This is sine function. So when you move, the x will remain here. Then it becomes sine inverse. Okay, sine inverse. So bracket 0.36. Then you just look for sine inverse. So what is the answer? You just have to make sure that it is in the radian mode. And then how do you press this? You just press shift and sign button. Okay, shift and sign button. You will notice that your calculator come out with sine inverse already. Then you just press the number again. Okay, so it's the same thing. This one move to here will be cosine inverse. So x is equal to cosine inverse 0.8021. So cos inverse, you just press shift then cos like that. Same thing for tangent. Okay, so I want you to find all these three. It's quite simple and easy. Okay, so now let's go continue with our learning objectives today, which is you have to state the arc length, the area of sector, and also area of sector. Okay, different ways of writing it. So where the theta is in radian. Okay, don't forget, I keep emphasize, circular measure all works with radian. Okay, we're not going to do with radian. We're not going to do with degree. Okay, so I knew that you all have learned circle theorem, but I'm not really sure have you learned area of sector. I think you did, right? So it's a bit different because the one you learned in Maths D, it's in degree. Okay, so it's like area of sector. What is the area of sector? Area of sector you learn is theta of, is it theta? Theta over 360, right? Times, its area is pi r squared, isn't it? Right? Yeah. Then if circumference, you learn arc length. Arc length you learn is theta over 360 times 2 pi r. Correct or not? Okay, that's what you have learned, right? Yeah. So let's see what is the difference in maths. Okay. So now before we go further, let's understand again. Let's go through again about the circle property. So if you have a dot extend from the radius, okay, so you form a sector. Okay, this is just like a pizza, right? It's a pizza shape like that. So this is called minor sector, okay, because you have a small sector shape. Then after that, the big one, okay, so this is a small one, right? So the big one is called a major sector. Okay, you have to draw it, so you remember, because why this is very important. Sometimes the question will not draw the diagram for you, but they will tell you instead, like saying that please find the area of the major sector, like that, you know, so you will know, oh, okay, major sector is the bigger size, like basically, yeah. So minor sector is a smaller size. So what comes with it is, this is the radius, right? And then again, this one is the theta. Okay, theta is the angle in radian. Okay, don't forget that. So theta. So how do you find the arc length? Okay, so how do you find the arc length? So arc length depending on, so what is arc length of the minor sector? So this is a minor arc length. Okay, because it's for the minor sector. So the bigger one, the major sector will be a major arc length. Okay, so it will be major arc length. So you must remember all these terms. Okay, so but it's quite easy, isn't it? Minor arc length, major arc length, like that. Okay, so how do we find the arc length? If you see, this is a theta, right? Okay, if we go back to the formula here, yesterday what we learned 360 is 2 pi, isn't it? So if we substitute 360 is 2 pi, so become 2 pi, right? Over 2 pi times 2 pi r. So 2 pi you cancel out. So that means arc length for theta, for arc length for angle in radian, it's going to be theta r. Okay, so just theta times r. That's why it's theta r. So that's the reason why, if you remember yesterday, that's how we come up with here, right? If this is 2, that will be 2r. This pi over 2, then it's pi over 2r. If this is 2 pi, the angle is whole 2 pi. That's why it's 2 pi r, isn't it? Like this one also, the angle is 180 degrees, which is pi in radian. So that's why the semicircle, arc length for semicircle is pi r. Okay, that's the reason why. So in short, because of the arc length you have learned in your Maths D, the 360 is actually 2 pi. So if we substitute 2 pi, we cancel out, we get theta r, right? So that's why when in the radian mode, okay, when in the radian mode, our formula for arc length is just theta r. As simple as that, okay? So arc length is equal to theta r. Then after that, let's look at area of sector, okay? Using the same idea, if you think that this one is 2 pi, okay? So that means it is theta over 2 pi times pi r square, isn't it? So the pi you cancel and I just left with 2 here. So that means it's theta r square over 2. Theta r square over 2, right? So it's theta r square over 2, and 1 over 2 is just same thing as half times theta r square. Okay, it's the same thing. So it's half times theta r square. So that's what we call area of sector. Okay, of course, if it's major, okay, then we'll say, what? How about major sector? Major sector or major arc length, you're still using the formula, the same formula, but it's just that the angle would be different, right? It's very obvious. If this minor one is theta, so the big one will be what? The big one will be 2 pi minus theta, right? Because the whole thing is 2 pi. It's just like if this is 60, what is the rest? It's 360 minus 60, right? Yeah, it's the same thing. Since this is in radian, so that means the whole circle is 2 pi. So it's 2 pi minus theta will be the major angle, like that. So this one angle is depending, okay? You have to find a major side, you use a major angle. If you want to find a minor side, you use a minor angle, okay? Okay, now let's go for this. This one is a line, what we call, I hope you still remember. Let's start from C, okay? This line is called chord, okay? So the chord, so radius, this side, when you draw radius, it divides a circle into sector, right? It divides a circle into sector. But when you have a chord, that means it does not pass through the circle. It does not pass through the center. Okay, so you can have this one also is a chord also, isn't it? It can be a chord, can be any. So this one also can be the chord. Yeah, I don't want to draw too much. So basically, you know it, as long as it does not touch pass through the center, it is always a chord. If it passes through the center, it means that it is diameter. Okay, so that is the difference. So now, a radius divides a circle becomes sector. Chord divide a circle becomes segment. Okay, so this small one is called a minor segment. Okay, you have to remember all these words because they will use all these words sometimes. So the bigger one, of course, will call a, okay, assume there is no line here, later you misunderstood, okay? Okay, so I just want to tell you that chord can be drawn in any way. So now I use the back to cross out the line. So this big one will call a major chord. Major segment, okay? Yeah, so what's so special about this segment? So sometimes you will be asked to find the segment, okay? Okay, for example, how later we see. So now we want to find first what is area ABC. So for example, this is the chord, and then happen to be that the end of the chord is joined with the radius as well. It's joined with the radius as well, okay? So you can see that we form a triangle, isn't it? We form a triangle. So that means, and then if this is the angle theta, okay? So this triangle, okay, this triangle, it's actually the area, it's half times r square sine theta, okay? So that is a formula. You will, I cannot show you how because you don't really learn how to do the Soka Tua yet. But well, actually, if I heard Cikgu Nadia said you did learn a bit already about So it's the same, it's kind of the same thing, yeah? You just divide by 2, then it's 90 degree, and then because of the Soka Tua sine function, opposite side over hypotenuse, right? And then at the end of the day, after we do all the working, then you will actually get half r square sine theta. If you not remember, never mind. I mean, if you don't understand how to get this, never mind. You just remember the formula. It's half r square sine theta. Or in fact, you can actually have AB sine theta. Actually, the AB is actually the two side. That's that's where beside the angle one, okay? But happen to be this is R and R, that's why I say R squared at the beginning, okay? Otherwise, these two is quite similar. But this one is for circle only. This is for circle only, okay? This is for general. General means, for example, if you have this kind of triangle, you also can use it. Doesn't mean you have to be in circle. But this one has to be in circle, okay? So that's the different thing only. Okay, so this area of AOB, so maybe you have to, I want you to label here AOB, otherwise later you all confused. Okay, so this AOB. So how do we find, so how do we find the area of segment? Okay, area of segment. So for area of segment, it's basically the red color one, isn't it? The red color one. So what happened is we know the area of sector here, isn't it? If you see it, this is area of sector. So, okay, so basically area of sector, you take away, you minus the triangle, right? Then you'll get the segment that you want, isn't it? Okay, this segment is coming from here, right? You see, so you cut it away, you will get this one. So what is the area of sector? Come back here. So it's half, okay, sorry, so it's half theta r square minus the area of triangle, which is just at the top, so half r square sine theta. Okay, if some of you we want to be more like simplified, so I can take the half r square, so I just left with theta minus sine theta. So this one is the area of segment. Okay, that's how we find it. So now you try to draw the diagram properly and then step down the angle, the formula properly. Okay, so now you just have to recognize how the diagram should look like, what the theta stand for, okay, what is the r, how we get the segment like that. Then if you understand all of this, then you are ready to go for the learning objective 1004. Basically, it's just that we just have to find the arc length and area of sector. It's quite straightforward. You just find the arc length and area of sector. You just try to understand. If you don't have diagram, as I said, you try to understand. So find the length of arc length, which subtend an angle of, that means the angle, the theta is 3 pi over 2 at the center, right? And then that's mean the radius is 8, okay? So find the arc length. And then they say, oh, if this is for A, right? And then they say, if the radius is 8, find the angle subtended by an arc, then the arc length is 6 centimeter like that. Okay, so you try to find it. So I want you to do example 6 as well. So example 6, basically, yeah, okay, if you understand just now what I have explained in this page, you should be able to do these two questions. Okay, that's it for today's lesson.